In the previous tutorial, I could not provide some desired contents due to some system problems. So today I am repeating the same session with the important chapter concept overview. Please you take the screenshot. I am now explaining one by one. Consider two non-empty sets A and B. Okay. So already you know from the topic of A cross B that A cross B is the set of all ordered possible pairs which can be formed from A to B. Okay, total set. And from that set, so many subsets are possible. Now, a relation is nothing but a subset. Any subset is called a relation. This is the definition. Okay, a subset belonging to A cross B is called a relation from A to B, which is formed under certain rule. Remember, this one is the simple definition. And a relation is denoted by R or this one. R is a relation from set A to B. These are very important and they will be used according to situation. And the possible number of relations belonging to A cross B is given by 2 to the power PQ, where P is the number of elements in set A and Q is the number of elements in set B. Okay, you must remember that one, but the proof is not in your syllabus. And with this result, we are testing our exercise 2.2 question number 8. Okay, where it has been given that A is equal to xyz, B is equal to 1, 2. It is asking that find the number of possible relations. So you see that solution number of elements in A is equal to 3 and number of elements in B is equal to 2. So what is the possible number of relations? It will be given by 2 to the power pq is equal to 2 to the power 3 into 2 is equal to 2 to the power 6. You can stop here, but I am showing you that, see, from these few elements, 64 such relations are possible. Okay, so this is the answer. By the way, we have done one problem from the exercise. Now we are understanding how to describe a relation in terms of roster form, set builder form, and arrow diagrams, and how to find the domain, range, and codomain. Okay, so consider sets A and B such that A is equal to 1, 2, 3, 4 and B is equal to 3, 5, 6, 12. Now to understand the arrow diagrams, you must understand how such a roster form set is denoted by pictorial diagrams. So I am drawing that one. See, the equivalent pictorial diagram of this is that. Okay, the two curly braces are like that, a closed curve. Same way, closed curve. And the elements are written vertically without comma. And the name of the sets are written beside the diagram without equal to sign. Okay. But if equal to sign is given by somebody, it is not a wrong but not customary. Okay. So this is the pictorial diagram. Arrow diagram starts forming whenever a relation is going to be defined by a rule. See, we have defined a set builder form. R is a relation of the ordered pairs A, B such that 3x is equal to y, where A belongs to A and B belongs to B. Okay, so this is a rule actually. So now starts forming the arrow diagram because of a relation defined. Okay, so first thing that you have to show the relation symbol with the letter R, and now by this rule we are connecting the elements there. After completing this will be an arrow diagram. If you take x1, then 3 into 1 is equal to 3. So we have got one element and start here writing the roster form. 1 and 3 is one element under this rule. Okay, now 2 will be related to this because 2 into 3 equal to 6. So one more pair. Then 4 into 3 equal to 12, and this 12 is available here. So we got another pair 4, 12. Now we shall See the elements identification names. See, we can identify the elements by these three combinations. Okay, either first element and second element, or mapping elements and mapped elements, or pre-images and images. Let us understand them. First elements means all those elements which are connected to that set, and second elements are those which have been connected in the relation. And mapping elements versus mapped elements, those elements from we are going to match there are called mapping elements, and the elements which has been matched are called mapped elements. Another is that, for example, 2 has gone to 6. Those six of the set V will be called an image of the element 2. And conversely, the 2 is called the pre-image of the element 6. Okay, these are the things you have to remember. Having understood these terms, we shall go to define the domain, range, and codomain of the relation. So, domain of R is the set of all first elements, and range of R is the set of all the second elements, and codomain of the relation is this total set itself, okay, in which the first elements are constant to all. So for example, now domain of R of this relation, it will be set of all those 1 2 4, and range you tell me 1 to 3, 2 to 6, 4 to 12, 3 6 and 12, and codomain is the total set 3 5 6. So I hope that you have understood. Are you now ready to test your knowledge on relation concept? Okay, take down please. I am starting from the exercise 2.2. See the questions 1 and 3 here. After that also we shall do other problems. Now I am taking the question number 3 first of all, which is very easy to understand and gradually rise up. Solution 3, A is equal to 1 2 3 5 and B is equal to 4 6 9. See that the difference between X and Y is odd. X belongs to A, Y belongs to B. The questioner does not say anything about positive or negative integers. To tell you either it is positive or negative. If it is odd, then you can take the ordered pairs. Okay, you have to understand the question first and then answer. Right, starting the roster form. See, 1, if I take with 4, then 4 and 1 difference is 3. So I can accept it. 1, 4 as a pair. And then 1 with 6. It is also difference is 5. 1 and 6. And then take this one with 9. So 9 minus 1 is equal to 8, or 1 minus 9 is equal to minus 8. Whatever it is, the number is coming even number. So I cannot take. Now come to 2. 2, 4, it will give the difference of even number. 2, 6, again even. And 2, 9, it is odd. 9 and 2 difference is coming 7. So you can take 2, 9. Then come to see 3. Compare these 3 with all of them. 3, 4, difference 1. So 3, 4 I can take. And then 3, 6, again difference is 3, odd number. So 3, 6. And then 3 minus 9 will be minus 6, which is even. Now come to 5. 5 minus 4 is equal to 1. So I can take one more, 5 and 4. And then 5, 6, another one, 5, 6. Then 5 minus 9 is equal to minus 4, or 9 minus 5 is equal to plus 4, which is even. Cannot take. So we have got R is equal to 7 elements, which is in the roster form, and that is the answer. Now we are taking the question 1. A is equal to this. Okay. R is equal to y such that 3x minus y is equal to 0, where x, y belong to set A. I can write like that. 3x minus y is equal to 0 is nothing but 3x is equal to y. Very easy format. Now you convert it into roster form by seeing this relation. So if you are taking x is equal to 1, then 1 into 3 is equal to 3, it is here. So 1 comma 3 is one element, and then 2. 2 into 3 is equal to 6, it is there. 2 comma 6, and then 3. 3 into 3 equal to 9, 9 also present. So this pair is satisfying that. And then 4. 4 into 3 equal to 12. Look at here, yes, 12 is there. Then 5. 5 into 3 equal to 15, but 15 is outside the set. So closes here. Okay. Now you have to find out the domain, range, and codomain. Domain of R is equal to set of first elements 1, 2, 3, 4, and range set of second elements 3, 6, 9, 12. And codomain, you see that the total set itself. This is the answer. Now I am taking a problem equivalent to your exercise question 6. Very important, very interesting. Read the question, which can be in two formats. That A is equal to 0, 1, 2, 3, 4, 5. Define a relation R from A to A as R is equal to xy such that y is equal to x plus 5, where x, y belong to A. Find the domain, range, and codomain of R. Or a relation R is defined by R is equal to xy such that y is equal to x plus 5, where x, y belong to the set 0, 1, 2, 3, 4, 5. Solution: given relation R is equal to xy such that y is equal to x plus 5, where x, y belong to the set. Okay, so equal to we can write by seeing here you start. If x is equal to 0, then y is equal to 0 plus 5 equal to 5. This 5 is here. So I have got one element 0, 5. And then you see, take 1. So 1 plus 5 equal to 6, but 6 does not belong to this set. So here finish. Now you find the domain, range, and codomain. Okay. Hence the results. TR is equal to, what will you please tell me? Only one pair and the first element is 0. So it will be 0. And range is equal to 5, second element. And codomain 0, 1, 2, 3, 4, and 5. Okay. This is the answer. Very nice question. And your exercise 2.26 question is similar to that. But y was not restricted there, and that this element was inside. Okay, saying that only x comes from that. Now we are taking question 7. Write the relation r is equal to x cube such that x is a prime number less than 10 in roster form. Solution: r is equal to x cube such that, so if this is the statement in set builder form, then you can write r is equal to set of all ordered pairs x cube such that x belongs to, means you find out all the prime numbers less than 10. So first prime number is 2, then see 3, after that 5, after that 7. Because in this statement it is difficult to immediately get in mental picture what are the numbers. So first I convert them by thinking here like that 2, 3, 5, 7. Then immediately I can see by seeing this condition, and I can write fill up the roster form. So first element take 2. The condition is this. So 2 cube, 2 is one element. 2 cube will be 8, and second element take 3. So 3 cube will be 27. So 3 comma 27. After that take 5. 5 cube is equal to 125. So 5 125, and then 7 into 7 into 7. Okay, so this is the answer. Today I am going to finish here because video is going to be longer. Next day we shall solve the question number 9 from exercise 2.2, and one more standard problem or exemplar problem I will take, and then we shall go to understand what is function. Thanks for watching.